किसकी जरूरत है टेबल्स याद रखने की। क्यों? वाई बिकॉज वी आर गोइंग टू सी टुडे प्राइम फैक्टराइजेशन। क्या करना है प्राइम फैक्टराइजेशन में? इधर देखो। So prime factorization of 3825, there are two rules. First is it should be a prime number. First, whichever number you'll get, it has to be a prime number, and prime factorization should be in ascending order only. So let us start prime factorization of 3825. You can see this number is divisible by 5 because it's an odd number. But no, as per the rule of ascending order, it will be first you have to see whether it is divisible by 3. So let us check for 3. 3 ones are 1, 3 twos are 6, and then 3 ones are 1, 3 twos are 6, 2 sevens are, and then we'll get 5s are. So yes, it is divided by 3. So now we have to check it again. Next number, is it divided by 3 or 5? So I can see it is also divided by 3. That is 4, then 2s are 6 and 5s are. Now this number also you have to check again whether it is divisible by 3. So I can see it's not divisible by 3. So now I'll go for 5. 5, 8s are, and then 5s are. Then again I can see this is divisible by 5. 17 5s are 85. 17 is a prime number, so 17, and then it is done. So prime factorization of 3825 is 3 2 times, therefore square, 5 2 times, therefore square, into 17. This is the prime factorization of the number 3825. I hope you have understood. So we are going to start with now exercise 1.1 question number 2, where we are going to see find the LCM and HCF of the following integers and verify that LCM into HCF is equal to product of the two numbers. So the two numbers are 510 and 92. So we are going to prime factorize this as they are asking us to find the LCM and an HCF. First step of finding LCM and HCF is to prime factorize. So 510, you can see it's a even number, so it is first divisible by 2. 2 2s are 4, 1 remain, 2 5s are, and then 2 5s are. I can see 255 is an odd number, so I have to first see whether it is divisible by 3. So by 3 it will not be divisible, so I'll go by 5. No, it will be divisible by 3. 3 8s are, and then 1 remain, 3, okay, 15. Then 85, this 85 is not now divisible by 3, you will go by 5, and then we'll get 17. 17 5s are 85, so 17, 7, then 1. So this prime factorization of 510 is done. Now let us do for 92. Again, it's an even number, so it will be divisible by 2. So 2, 2 4s are 8, and 1, and then we'll get 6. Again by 2, you'll get 23. 23 itself is a prime number, so 23 is not divisible by 20. 23 is divisible by 23 only, so 1. So now I will write down 510 is having prime factorization 2 into 3 into 5 into 17, and 92 having prime factorization 2 into 2 into 23. So if I have to see now HCF, that is highest common factor, I will see the common number between the two, which is 2. So HCF is 2 itself. And then we have to see LCM. We will take the common number, which is 2. And you will also take all the left out numbers. So if I multiply all these numbers, I am getting 23,460. Okay, so first question, that is LCM and HCF. Finding LCM and HCF is done. Now let us verify this rule. LCM into HCF is equal to product of the two numbers. So I'll take LCM. First of all, I'll take LHS. Okay, so LHS is, left hand side is LCM into HCF. LCM is 23460 and HCF is 2. So if I multiply this, I'll get 46,920. That is my equation number 1. That is LHS. Now let us go for RHS. RHS is product of two numbers. Okay. So two numbers which are given in the question are 510 into 92. So if you multiply again these two numbers, you will get 4690. 920. That is equation number 2. So from 1 and 2 we get LCM into HCF is equal to product of two numbers. So hence proved. Okay. So this is done. Now let us go to the next question. Okay, so let us start the third question of exercise 1.1. Find LCM and HCF of the following integers by applying the prime factorization method. First question is 12, 15 and 21. So we have to do the prime factorization of 12 first. What is the prime factorization? It's an even number. So 2, 2 6 are again 2, then 3, 3 is a prime number. That's done with 12. Now let us do for 15. 15 it will be, it's an odd number, so it is surely going by 3 first, then 5, then 5 is a 1. The next comes 21. 21 again is a odd number, so you will divide it by 3 first. 7 3 is a 21, 7 is a prime number, so done. So you can see here 12 is 2 into 2 into 3 and 15 is 3 into 5 and 21 is 3 into 7. So now we have to see what is the HCF. Please see, is there any HCF coming to us? Yes, we can see 3, 3 and 3. 3 is common between all the three numbers, so HCF is 3. And now we will see LCM. First we will write the common number, which is 3, and then we'll write 2 into 2 from the first number into 5 next, and last is 7. So you multiply this and you will get the LCM as 420. So you have to write the final answer in the way, if there are more numbers you will write HCF of 12, 15, 21 is 3. LCM of again 12, 15, 21 is 420. Similarly, we are going to see the next question, and the next question is 17, 23 and 29. Okay, so now if you see, these three numbers are already prime numbers, so they are not coming in any of the table. So what you will do, you will simply write 17 as 17 into 1, 23 as 23 into 1 and 29 as 29 into 1. So if you see the HCF, highest common factor between these three numbers are all 1. So it is HCF is 1. Then you go to LCM, you take this 1 which is there common for all, and then you multiply 17 into 23 into 29. If you do this, you will get LCM as 1800. Again you write HCF of 17, 23, 29 is 1, and LCM of again 17, 23 and 29 is 1800. I hope you have understood this question. Let us go to the next question, question number 4. Okay. Okay, so now let's see the fourth question. That is, it is given that HCF of the two numbers 306 and 657 is 9. Then you have to find the LCM of the two numbers 306 and 657. So how do we start this question? We have to state the relation between these two, which we have already done. What is it? HCF into LCM is equal to product of two numbers. Out of that, LCM, HCF is already given, that is 9, and they're asking us to find the LCM, which we don't know, and product of the two numbers which are given in the bracket 306 and 657. So to get LCM, we will bring 9 down over here, and you will get 306 into 657 whole divided by 9. So how you will get this? Yeah, if you try to divide this, this is done by 3, then 3 ones are 1, 0, 3 twos are 6, and again you can do it by 3, 3 twos are 6, then 3 ones are 1, so we are left with 2 nines are. So if you multiply these two, you will get the answer as 2, 2, 3, 3, 8. So you can write LCM of 306 comma 657. If you do, it is 22,338. Okay, so let us go to the next question, that is question number 5. So let us start with the next question of exercise 1.1. We'll read the question. Check whether 6 raised to n can end with digit 0 for any natural number n. First thing that we will do is we will prime factorize 6. That is 2, 3, 3s are 1. So we can see 6 is equal to 2 into 3 into 1. This is its unique prime factorization we know. So if this number raised to any natural number n, then also you will get the same factorization. Okay, that is the meaning. So now if they are saying if 6 raised to n ends with digit 0, if it is the case, then it will be divisible by 5, right? Then it will be divisible by 5, right? Because if that is divisible by 5, then 5, that therefore 5 will be what? 5 will be, or 5 will be the prime factorization, or 6 raised to n will contain. We can write 6 raised to n will contain 5 as a factor. If it ends with 0, then it is divisible by 5. If it is divisible by 5, then in the prime factorization of 6 raised to n, it will contain 5. Okay, but we can see there is no 5 in this 6 factor, and if this is the case, it will contain 5. Therefore, as we know the fundamental theorem of arithmetic, there is only one way of having a prime factorization of any number. We will write, therefore, by uniqueness of fundamental theorem of arithmetic, there is, or there are, no other prime in factorization of 6 raised to n. Okay, so so there is no value of n for which 6 raised to n ends with 0. Again, I'll explain. First, I've done what? Prime factorization of 6, which shows 2, 3, 1 are the prime factors of this number 6. But if it is supposed to end with 0, that means it is divisible by 5. That means the factors of 6 raised to n will contain 5. But this way, it contradicts the uniqueness of the fundamental theorem of arithmetic, and therefore there is no other prime factorization of 6 raised to n. There is no value of n for which 6 raised to n ends with 0. Okay, so let's go to the next question, question number 6. So I'm going to start with the next question of exercise 1.1. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So composite numbers are the number for which there are factors which are more than 2. If you get factors more than 2, then we say these numbers are composite numbers. So let us take the first combination which is given here, that is 7 into 11 into 13 plus 13. Okay, so this is 77 into 13 plus 13. If you do 77 into 13, then you will get 1001 plus 13. If you add this, you will get 1014. Now, if you take the prime factorization of 1014, but obvious it is a even number divisible by 2, so you get 5 and then you get 0, 7. Okay, then this is divisible by 3 further, 3 ones are 1, 3 6 are, and then 3 nines are 169 is square of 13. So, and 13 is a prime number, so 13, 13 and 1. So we can see 1014 prime factorization is 2 into 3 into 13 into 13 into 1. Okay, since it has more than two factors, 1014 is a composite number. Okay, let us do the next calculation. Into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So if you multiply this first part, it will come to 5040 plus 5. If you do, you will get 5045. So now if you prime factorize this 5045, first see it's an odd number, so whether it is going by 3 or not. So I don't think so it will be divisible by 3. It will go by 5. 5 ones are 1, then 0, then again 0, then 9. 1009 itself is a prime number, so it is not divisible by any other number. So 1009 ones are. So you can write this as 5 into 1009 into 1. So you can see there are more than two factors of 5045. So it will therefore, since it has more than two factors, 5045 is a composite number. So both are the composite number. That is what is the question. Explain why they are composite numbers. I hope you have understood. Okay, let's go to the next question. Okay, now let's go for the last sum of the exercise 1.1. We'll read the sum first. There is a circular path around the sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes of the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at starting point? Okay, so first of all reading the question, इसमें LCM करना है, HCF करना है, क्यों करना है, कैसे करना है, वो कुछ समझ में नहीं आता. तो इसमें क्या करना है, ध्यान दो, सर्कुलर पाथ है. अभी ये सर्कुलर पाथ में एक ही पॉइंट से दोनों दौड़ रहे हैं. ओके, सानिया टेक्स 18 मिनट्स एंड रवि टेक्स 12 मिनट्स. तो अगर इसका HCF करेंगे तो कम आएगा, कम आएगा कुछ. इसका HCF करने जाएंगे तो वो 2 3 ऐसे कुछ 6 में आ जाएगा, तो इतना कम तो हो नहीं सकता. सो नाउ लॉजिकली अगर समझना चाहे तो इसके हमें करना है LCM. Okay, one way of doing this type of sum is to understand the given word problem logically, and another way you can see here on the other side I have written by using keywords. Now see, I told you LCM we have to do in this sum. So now see, all these keywords are there or not in the word problem. I can see together, meet again. I can see both, leaves at the same time. So if you see together, together again, meet again, smallest number, shortest, both, leaves at the same time, then surely you have to do LCM. And if you see greatest number which divides or minimum number of or greatest possible, ये वाले वर्ड दिखे तो आपको करना एचसीएफ है. ये लास्ट मिनट में अगर ये लॉजिकली नहीं समझ में आ रहा है, देन यू हैव टू गो फॉर द कीवर्ड एप्लीकेशन. अदरवाइज ट्राई टू यूज द लॉजिकल मेथड which is actually advisable. So now we know that here we have to do LCM. Okay, so they will again be if they start at the same point and they have to meet again after some time, then we have to find, we will write, we have to find LCM of 18 minutes and 12 minutes. So first factorize 18, then 3, I can see 3 3s are 1, then again 12, 2, 6, 2, 3, 3 and 1. Okay, so 18 factors are 2 into 3 into 3 and 12 factors are 2 into 2 into 3. Okay, so LCM, you know, you have to take common one time. So LCM of 18 comma 12, if you do, it is common one time 2, one time 3, and left out you will write 3 into 2 as it is. So you get 6 into 6, that is after 36 minutes they will meet again at the starting point, because it is very clearly said when they will meet at the starting point, and therefore they will meet together at the starting point after 36 minutes. Okay, so that's it for today, dear students. We are done with the first exercise of a real number. So this is it. We have already done with our first exercise of the chapter real numbers. I hope you have understood all the solved examples. And homework for today, I'm going to give you one homework. I want you to give me the answer in the comment box. Question is, prime factorize the number 1248 and send me the answer of this prime factorization in the comment box. Jhat pat patapat. Thank you. Bye. And don't forget to like, share and subscribe to my channel.